Elastic collision problem. All right, you've got a ball with a certain mass and it's hitting another ball, and you're going to have momentum conserved. So you're going to say m1v1 plus m2v2. This is the before, is equal to m1v1 plus m2v2. Now what I like to do is I like to call this is after. I like to find the after. I'll call this x and I'll call this y. Because then what I can do is I can graph this in Desmos. And for the second experiment, or this is momentum, or P really, and then I'm going to do kinetic energy, and I'll just do 1/2 mv squared. That's, m1 v1 squared plus 1/2 m2 v2 squared, etc. Now note that this term here and this term here, because the second ball game is he's at rest. This guy's at rest. And then we'll set that equal to 1/2, watch, I'll say mx squared plus 1/2 my squared. I'm going to then plug this into the Desmos, right? And I'll have a line, and then I'll have a circle, and then you're going to have 2 points, this point and this point or whatever, and where they intersect, only one set of those points is going to make physics sense. So you have to choose which point, and that will give you the answer to A and B, what the final velocities. Now don't panic, sometimes it may even bounce back, so you could have a negative velocity, so don't panic, but one of them won't make any sense at all. And then for the second part, what's the final velocity if they're both inelastic? Then it's just conservation of momentum, and you do this thing here, and you say equal to m1 plus m2 times v final, and you're just solving for v final.